Hello students, welcome to the classroom point. In today's session, we shall discuss the kinetically controlled product and thermodynamically controlled product and what is the meaning of these two things. So let us take one important molecule here. This is the molecule 1, 2, 3, 4 carbons are there. So but and 1 and 3 positions double bonds are there. So but 1, 3 diuc is the name of this molecule. So when this molecule is subjected with the hydrobromic acid HBr, we get two products. This product is called the 1,2 addition product and this product is called the 1,4 addition product. Why this one is called the 1,2 addition product? Because HBr is going to add at the 1 and 2nd positions and giving this product. And 1,4 addition product means HBr, H plus and Br minus ions will respectively add at this particular 1st position and 4th position. So the molecule, the product obtained in this process is called the 1,4 addition product. Now let us see how these molecules are formed and why they are, which one is called the kinetically controlled product and which one is called the thermodynamically controlled product, just by seeing the mechanism. So whenever you take the butadiene, 1,3-butadiene and add the H plus ion means HBr. So H plus ion preferably approaches this particular double bonded carbon atoms because the electrons pi electronic cloud is available. So one of these pi electrons will be shifted over to the this particular carbon, and there are chances to attack over here also, but according to the Markovnikov school, if H plus ion attacks over the carbon with more number of hydrogens, it will be able to provide the stable carbocation. So when these pi electrons are shifted over here, it gets the negative charge and negative charge attracts this H plus ion, so that H plus ion will form a bond over here, leaving the positive charge on this carbon atom. So we get this molecule which is a secondary carbocation which is stabilized by the resonance itself, and moreover it is having the hyperconjugate to alpha hydrogen atoms also. And this particular secondary carbocation even may participate in the resonance by shifting these pi electrons over here, so that a positive charge will come and sit in this particular carbon atom, giving the primary carbocation. So primary carbocation is less stable compared to the secondary carbocation. The moment secondary carbocation is formed, which is a stable carbocation, so without giving any gap, the available Br minus ion from the HBr immediately attacks over this positive charged carbocation and gives this product. Means immediately attacks means the speed of this reaction is so high, that means the rate of reaction is more high. So we say that the kinetics of this reaction is more high, so that this product is called the kinetically controlled product. So kinetically controlled product is always formed from a stable intermediate. So if stable intermediate is there, means automatically next attack can easily takes place and immediately produce the required product, and this reaction does not need any heat energy. So that's why most of the kinetically controlled products or the reactions are takes place at the low temperature. And now let us come to this primary carbocation. This primary carbocation is less stable in comparison to the secondary carbocation. Means we are creating a unstable or less stable carbocation from the stable carbocation, for which we need to provide the temperature, so that this shifting of this pi electrons will take place and gives the less stable carbocation. After the formation of the less stable carbocation, Br minus attacks over this particular positive charge and giving this molecule. So this molecule is formed after the giving of certain amount of the temperature, and this is called the thermodynamically controlled product. And moreover here we are giving the temperature, so this reaction takes place at the generally at a high temperature. And one more important thing to be noticed here is kinetically controlled product. In this particular case, this is an alkene and here the double bond is there, and more substituted alkenes are more stable. So thermodynamically controlled product, here it is more stable because of the presence of the means more substituted alkene, and here less substituted alkenes are there. So kinetically controlled products do not wait for the whether the product is more stable or less stable. They wait only for the stable intermediate. Once a stable intermediate is formed, immediately a product will be giving, they will produce the product. But in the case of thermodynamically controlled product, they wait till a stable molecule is going to be formed. So this is the difference between the kinetically controlled product and thermodynamically controlled product. Now let us take one of the important question here. Say this is the molecule given and HBr in the presence of the CCl4 and no temperature is mentioned. So once no temperature is mentioned, you must remember that the reaction is going to be takes place at the room temperature. Room temperature means 25 degrees centigrade, usually high temperature. Usually here I said low temperature means these are negative temperatures, minus 25 degrees centigrade, and high temperature means approximately 40 degrees centigrade, nearly to the room temperature. So that whenever no temperature is mentioned, you have to go for the 1,4 addition product. So here this is the 1,2 addition product and this is the 1,4 addition product. 1,4 addition product is the major product. Let us see why this is going to be formed again. See, this is the molecule we have taken, and H plus ion is going to attack either this double bond or this double bond. But H plus ion preferably attacks over this double bond. Why? Because if H plus ion attacks over this particular carbon atom, these 5 electrons will be shifted over here and giving the positive charge to this carbon, which is a tertiary carbocation. So tertiary carbocation is more stable. So immediately Br minus attacks and gives the kinetically controlled product. But we are giving the temperature. Since we are giving the temperature, so the stable intermediate will be converted to the less stable intermediate. This is the primary carbocation, which is less stable. Now Br minus attacks over this less stable carbocation and giving the 1,4 addition product. So now let us see here. So in these products, kinetically controlled product is 1,2 addition product, and thermodynamically controlled product is 1,4 addition product. So dear members, I hope you understand my explanation. So if you understand my explanation, do not forget to like this video, share, comment, and finally do not forget to subscribe this channel. Thank you.